Okay, so we're going to go over vectors. There's two definitions that go along with vectors. In order for something to be a vector, it needs to have magnitude, and it needs to have direction. Okay, so there's many things that have one or the other. Magnitude, a lot of times when we talk about magnitude, you may talk about mass, age, weight, right? All of these things have magnitude, but unless told, they have no direction to them. Direction is essentially direction, heading north, south, east, west, all of those, right? North, south, east, west, or a bearing. And we're going to talk about bearings. And we're going to talk about specifically direction and then how we can apply them to vectors, okay? So if we talk about a bearing, what we're referring to is an angle from the measurement of north, okay? So hopefully you've seen a compass. And let's go on the assumption that this would be north. If we're on our Cartesian plane, that would look like the y-axis, okay? So north would be heading in a positive direction on the y-axis, okay? So if we're talking about a direction when we get something, we're talking about how far of an angle heading in a clockwise manner, how far we are from north, okay? So if I was at, let's say, the x-axis heading in a positive direction, this would be how many degrees from north? 90. So this would be considered a bearing of 90. On a compass, it's known as traveling east, right? This is west, this is south. If we were to go 180 degrees of north, our bearing would be at 180 degrees. This one was 90. That would be the same as traveling south, okay? Same idea, if we were to go 270 from north, we'd be heading west. And if we go 360 from north, what are we doing? We're going back to north. That's redundant. There's no reason to say that, right? So when we talk about bearing, it's always clockwise from north. Oh, we don't need that. Thank you. Thanks for that. Okay, so when we're talking about direction with all of our vectors, we are going to either refer to a bearing or there's another way they may refer to it in your book. And if they refer to it this way, it's a little different. We'll put a second example here. Yes, they'll talk about within the specific quadrants. Okay, and again, your quadrants will be broken up into north and south, and east and west, okay? So if we have a specific vector, let's say, that's heading this direction, and in this case what we'll say is, maybe this is, I don't want to say 45, let's say it's 60 degrees, okay? On a bearing, we know this is 60 degrees. Another way they may represent this is they'll say it is north and then 60 degrees to the east, okay? So the first letter is the direction where we started. So we started on our north, which is our y-axis, and we headed 60 degrees to the east. That's what the second letter stands for when we're talking about our directions, okay? I can also represent this as saying this is east. Anyone know what this angle will be? 30. So we'd say it's east 30 degrees to the north, okay? So I can represent that two different ways, or we could have said it's on a bearing of 60 degrees. Now that bearing will change. When we're doing it this way, with our northeast or east-north, we'll never go above 89, okay? Reason I say 89 and not 90 is because if we're not north and I said move 90 degrees east, I would just say I'm heading due east. It's all broken up into 90 degrees or into the 4 quadrants, okay? So these numbers should be below 90. If they're not, you might have to work with them, but when written in the book, they should be written that way, okay? So that kind of talks about direction for us. And magnitude, think of it, and the best explanation is usually like a plane flying, or even driving a car, you could say. If you're a plane, I'm very good at drawing planes. Whoa, hold on. Check this out, boom. Look at that plane. Oh, it has arrows, so it ruined it. That's okay. So here's our plane. It's flying east, okay? So that's direction, and we'll say it's flying at 700 kilometers an hour. That is magnitude. So this is now a vector. This plane's direction and speed are considered a vector. If you were to only tell me the speed of something like a car, here's my wonderful car. Draw this little beetle. Look at this thing. This thing's very fast. Okay, this thing is going 1,000 kilometers an hour, but it has no direction. Therefore, it's not a vector. Okay, so that's the difference between a vector and a scalar is something with just magnitude. Okay, so in this case, this would be considered a scalar. Scalar. I spell it scalar. Yeah. So this would be considered just a scalar. It has magnitude, but it has no direction. Okay. So now, let's get into our notation for vectors. When we talk about a vector, we'll usually talk about a starting and end point. So I'll use this arrow here. So here's my vector. And we'll say this is the starting point A and B. Okay? So in other words, if I'm to name this vector, the way we write it out is we'll put the starting point as the first letter and our ending point or direction as the second, and we put a little arrow on top saying that direction. In other words, we're traveling from point A to point B. So this is our notation for a vector. Okay? So if I'm written like this, this means I have something that has direction and magnitude. This can also be represented as the absolute value. The absolute value of AB, or this vector, would be strictly the magnitude. Okay? So let's say this is a vector going at maybe 50 kilometers an hour, and it is on a bearing of 45 degrees. Okay, so remember that's from north, it's on a bearing of 45 degrees. That would help me describe this notation of the vector. But if I have the absolute value or the magnitude of the magnitude of vector AB, where's my pause button? So the magnitude of this vector AB would be simply 50 kilometers an hour. Simple idea. You can have vectors that are not parallel but have the exact same magnitude. In fact, they can be doing completely different directions. Okay? An example of this is I'm going to create another vector on this page. Here's our second vector. Let's do it as an arrow, actually. Thank you. So here's our other vector here. A very different direction, we'll call this guy CD, the ancient CD. Okay, so this is vector CD, let's call it. The direction of this vector, we'll say is on a bearing of 135. Okay, so 135 degrees, which means it's pretty much 45 degrees south of east. Okay, that would be a bearing of 135. Notice my bearing is from north again, right? Does that make sense to you guys? Yeah? Okay. So this is on a bearing of 135, but it is also going, let's say, 50 kilometers an hour. Okay? So we know that vector AB does not equal vector CD. These are not the same. They're going very different directions. But we could say that the magnitude or the absolute value of AB is equal to the magnitude of vector CD. Okay? So when we're talking about absolute value, we're talking about the magnitude of a vector. And these two have the same magnitude. Therefore, I can make this statement that these vector magnitudes are the same, where the actual vectors themselves are not equal vectors. They're very different. Okay? So let's do the entire page here. Oh, get shadows. Okay, and finally, let's talk about a negative vector. Again, let's talk about vector AB. Kind of lags here. Vector AB, we already knew above, was heading on a bearing of 45 degrees at a speed or magnitude of 50 kilometers an hour. If I were to say I would like the negative vector AB, okay, the magnitude of the vector does not change. The magnitude of the vector is still 50 kilometers an hour. Oh, I don't want to do it in red. Let's change that to maybe green this time. The only thing that's changed in this instance is this is still going to be our A and our B. The negative is like reversing something. So the inverse of something. We're still at a magnitude of 50 kilometers an hour. but our direction has changed, and especially if we're talking about bearings from north. Okay, remember before we were on a bearing of 45 degrees. Anyone know what my new bearing would be? 135? It's more than that. I think it is. Oh, is it 215 or 225? I think it's 225. 225. So all we did is we're going to add 180 degrees to the original bearing. That's why bearings are sometimes easiest to use. There's some quick ways to change things. Our bearing, we add 180 degrees to it, which means we're now on a bearing of 225 from north. So the direction has changed the opposite way. In a bearing, it's a little different. Think of it like our arrow was here to start, and then when we do the negative, our arrow just goes to the other end of that vector. So it's heading in the opposite direction. All right, pause this and get your question. But I just want to add one other thing. Because it's negative, what if I find the absolute value of these two? So the absolute value of vector AB in comparison to the absolute value of negative AB. Are these going to be equal or not equal? They'll be equal, right? Our magnitude has not changed. And because it's an absolute value of something, it's still going to be at 50 kilometers an hour. Now we know that these two vectors are not equal though. The negative bearing gives it a very different direction. But again, the magnitude is the same. So just make sure we can get the negatives of vectors also.